I do like this.
I don't have my book here.
It doesn't matter, just if somebody has it, they can read it to me. What are you talking about? You took the picture. I took your phone.
Yeah, I have it.
Okay.
A man
Yeah.
is standing at the edge of the pool, which he knows is 1.2 meters.
Okay, hang on.
That's 1.2.
Oh, okay, I'm sorry.
Go on.
He looks down at the angle of 30 to the downward vertical. At what depth does the pool appear to be?
So he looks down.
At 30 degrees.
So we need to imagine. I didn't say how tall he was, so I'll just put his head here.
Well, you said standing on the edge.
Yeah. Don't.
His height's not important. I don't care about his height.
What?
If you did care, I would have told you his height.
Okay.
Right. So he's looking at an angle which is 30 degrees to the downward. So that means if I just put in my x and y here, the downward vertical is this. So in other words, this angle here is 30, and this angle here is 30.
Yeah.
Okay, and this n is 1.33. Yeah? And this n here is 1. What was my question?
What was the person can see? The
Yeah,
upper and the...
what depth does the pool appear to be?
Yes. Okay. So if you...
What is that mean?
I mean, how the person see.
Yeah.
How
So,
much light?
if the water wasn't water, if the pool was empty, okay, then when he looks down at 30, that light would travel at 30. So imagine he's looking at something on the ground here, and it would travel up here, and it would appear to just go in a straight line. So he knows that it's 1.2, and this angle here is 30. But of course that doesn't happen. Although he's looking, it's coming at him at a 30. It didn't leave the water at 30 because its angle changed. We just know that it came out to his eyes at a 30. Like, okay, I said he's standing at the edge of the pool, so if you want I could put him like here. And here's his eyes here. He looks like an alien. Here's his eye here. Put a little hat on him. He sees that as a 30. So we know that the theta 2 is 30. And if the pool was empty, the theta 1 would be 30. If the pool was empty. But it's not empty.
Now, isn't it 1?
No, but because he can see the bottom of the pool, the light is coming out from the pool. Like when I look at you, the light is traveling from you to my eyes, not my eyes to you. So this is actually the 2 part. This is the N2 and this is the N1. When I look at you, which way is the light traveling? Not from my eyes to you, because my eyes aren't flashlights.
No, it is. I mean, it depends on how your eyes look
No.
at it and then it reflects back.
If I can see the bottom of the pool, then the light is traveling from the bottom of the pool to my eyes. Of course it makes sense. Now, we know the theta 2. We know the N2 is 1. Actually, I said it there. We know the N1. So let's find the theta 1.
Okay.
So sine theta 1 over sine 30 is 1 over 1.33. So if I bring the sine 30 up, I get sine theta 1 equals sine 30 over 1.33. So theta 1 is sine inverse sine 30 over 1.33. What's that, please? 22. So the light must have been heading up at 22 degrees, not 30 degrees, so that it would leave at 30. Okay, so we've worked out this angle. This angle here is 22.1 degrees. Right, so I forgot what I'm asking you for. What's the question?
Yeah.
How deep does it appear to be? Okay, so when the pool was empty, this is 1.2 and that angle here is 30 and this one here is 30 and this distance here can help him judge the depth. So for example, if he sees this distance here is D over 1.2 equals tan 30. So D equals 1.2 tan 30. What's that D, please?
1.06. Wow. I think that's
No. 0.69.
What is it? 0.692 meters. Okay, that's fine. But in this picture, when he's looking at something which he thinks is 0.693, it's not really 0.693. How big is this distance here? This would be
4869.
1.2 tan 22. Yeah, okay. So what is 1.2 tan 22.1? 0.4873. Okay, so look, please, look very carefully. When he looks into the water and his eyes are looking straight down, his brain can't understand that the light is bending. So if he's looking down at a 30, his brain will feel like he's looking in a straight line, even though it's bent. It's not really 30. Okay, so this here, he perceives it as 30 degrees, but it's not really 30 degrees. It's like fake 30 degrees. But when he looks at the bottom of the pool, he will see this distance to be 0.4873. So he will not, the brain will not understand that to be 1.2. It should be something smaller. So tan 30 equals 0.4873 over H. So this is our answer. H is 0.4873 over tan 30. Now what's that? And that should be smaller than 1.2. 0.844 meters then. So that's how much how deep it appears to be. Now you know about this, what?
Why have you decided to use a hint? What is doing?
There's two things happening here, because I said the apparent depth, okay? When he looks at the bottom of the pool, he will see this distance and his brain will understand that's how big this distance is here. But what his brain will not understand is that the angle is not 30. So what will happen is, thinking the angle is still 30 and seeing the changed distance, it has the effect of making the pool seem not as deep. Now you know this, whenever you look at a swimming pool or a river, it never looks as deep as it really is. You know this. And the reason for that is there's two things happening. Your brain can see the bottom of the pool, but cannot understand that the angle is different. It's not a straight line. The two things go together to create the illusion that the pool is not as deep. This is the only way the brain can understand the picture. So the brain thinks this is a 30, but it also knows that this distance here is a 0.4873 because it can see this distance. Yeah. So instead, if there was a little fish here, the fish would look like it's here.
Steven,
Yeah.
so what point are we looking at?
What point is he seeing? Yeah.
We are talking about like from here.
Yeah?
It looks like floating above here, this point. So it feels like here, right? Feels like looking at here, this side.
Oh, you mean like, does this look like it's up here?
Yeah.
I suppose so, yeah.
Why this point? Not this point, this point, this point. It could be here, here.
It could be. But I don't really care what's happening here. Because I just needed to pick one point. Yeah, no, it could be here. Could be here. Could be here. My question, if you want to know where the fish appears exactly, that's a more difficult question. I don't care where he sees the fish, I just care how deep he sees the fish to be. But its exact position, you're right, it could be, maybe the fish doesn't look as deep and it also looks like it's a little bit in a different direction. But I don't really care about that, because my question was how deep does it appear? So to know how deep it appears, I need to know what length of pool he sees here. It's a difficult question, but the reason I put it in was because I did see this question once in the exam.
It's confusing.
Now, it is confusing, and the good news is it only happened once.
So it can be
A long time ago. A long time ago.
Different and
Wait, just before I continue,
Let me say this.
I will record it.
it's recorded, don't worry. Can you take this 844 and the 1.2 and divide it like this? And what do you get?
1.42.
What? What's wrong?
It's wrong. The correct answer is 0.9 something.
Huh? What's
Oh,
correct?
no, what are you doing? Where are we dividing that?
Oh no, I just want you to divide it.
Oh.
So that's
I want to see what number you got.
1.1.
Do you want us to surprise you with N? No,
N.
it is not.
You're looking at it N, yeah?
Perhaps.
We use that method. That's
Yeah.
how we get different answer.
N is because we use that for my
0.9 something. So teacher, there's something wrong with this.
Well, maybe you typed something in on the calculator wrong.
No, it's 0.9 0.902.
It's confusing.
Supposedly.
It's confusing that you're using what the mind.
Teacher, but in that case, the angle doesn't matter.
Ah, yes. That formula for apparent. Oh yes, so forget I said that.
Oh, sorry.
And that formula is only when you're looking straight down.
Was it?
Yeah, no, I remember this in middle school. It's when you're looking straight down, like
Oh, if you're going to straight down, your angle has no difference. So
Yeah, that's my point. I put an angle into it. That formula works when you're looking straight down, not at an angle to the river.
well, we just caught it.
Huh?
No, I have no idea what I'm saying.
Google it.
He did.
Yeah, but that formula you're talking about, the real over the apparent, that is only when you're looking straight down. You're above directly.
In this case, you say we have the illusion because of the angle that our brain
Yeah.
mistaken.
Yeah.
But if we are looking straight down, there has no mistake on angle. So how do we have that?
Yeah, well, it's because there is actually an angle, because when you're looking, I'll draw the picture for you. If you picture a cup with water in it, and here's your eye here, and you put a coin in it here, there is an angle because what you're looking at has a thickness. That's the angle part of it.
Quality is just a point. Like a paper, and then we make a point, and then we put a bigger on it, and then we look at it.
But if it's just a point, then this, like, I mean, how could you have just a point and no no thickness to observe. You know what I mean?
I mean like a paper, and then we dot a marker point, and then we put a...
Okay, so if you have a completely blank white piece of paper and a tiny dot on it, and this is full of water, and you look straight down, then you have no sense of depth. You can't judge how deep this is. You can't. There's not enough visual information to get a feeling for how deep it is.
Was it?
But you can't truly have a single point. Do you know?
Oh.
Like it will have some thickness.
Oh, we need thickness to determine the depth.
Yes. Because your brain is going to work out the depth from things like thickness.
Oh, our brain?
This question is quite difficult. But I had to give it to you because it was an exam question. Yeah. What's wrong, Monica?
No, she just started right now. The proof is
What? It sounds like, from what you found on your phone, it sounds like you'd have to prove me and other websites wrong, is it? Well, what's that? Okay. You're not happy that my formula for real over apparent is only when you're looking straight down?
I am though.
Yeah, and were you ever doing problems in high school where you were looking at an angle to the water?
Looking at coins from the side and I mean, if you look at it even from the side, I don't get how you're implying that the 30 degrees to be something from the man's brain.
Me too.
I was trying to use that as an explanation.
I don't understand why this distance gives us the illusion, the base distance.
I thought the base distance is engagement with the same.
The base.
Because you calculate the base distance.
I think in my attempt to try and simplify this problem to make it accessible, it's made it harder. I'm not using the base, the brain isn't necessarily using the base length. I'm just trying to show you how distances appear shrunken, or distorted, I should say. If this is confusing, I need to change this question to make it maybe, I might have to put this question into multiple parts or something like that. I can't think of. Monica, if I was to have a complete guess at what I think the formula is you're talking about, now this is a complete guess. You said the real depth over the apparent depth, isn't it?
Yeah.
That would be well, 1.33 over 1, isn't it? Or do I have that upside down?
No.
Anyways, what was I doing a moment ago? I was doing 1.2 over 0.844. Now, I think that formula only works when you're looking straight down on it. So if I was to have a total guess, I need to put something into the formula that takes account of the angle. So if I was to put in something that has a value of 1 when you're looking straight down, so when this is 0, I need it to be 1. So I'll put in a cost 30. Now, it's a total guess, but can you hit this in on the calculator and see what you get?
Teacher, it can't be. Because we use n equal to c over v is a ratio.
1, 2, 3.
No. So it's not this.
No, teacher.
What? Can I close this? This was supposed to be a quick question.
N equal to c over v, we don't have the angle either. But the light can be traveled in many angles into the glass.
I need to make a note to change this question. What? Yeah. Yeah.
Initially it was 22.1
Yeah.
and 4873.
Yeah.
Yeah, I guess so. It's small. I mean her small.
Huh?
No, I mean the brief.
I don't know what you're asking me.
The Jewish.
KJ, you have a question?
Yeah,
No.
Yeah.
I didn't go there. I mean the email.
I use oracle, like here, and I made
It was what?
my postulation was we are perceiving it here. It this point floating into here.
Oh, good. You're looking at it. Very good. No, let me try and do it that way too. Sit back down. We'll have a look at that. Oh, sit back down. We'll have a look at that.
I don't know.
All right. I'm going to do this.
How much of that?
I'm going to do this one again. But just KJ has another way of looking at it, and I just want to see if it gets the same answer. So, in the same way, you have your man here, yes, and you have the river here, and you have a fish which is, or something which is here, and that's 1.2, but it doesn't look like 1.2. Instead, it only looks like whatever. We'll call this distance here h. So, we'll put this point here. Now, actually, I'll draw my man later once I draw the lines in. So, his brain thinks the light is going like this, but of course, what's really happening is it's going like this and reflected up like that. Now, we said that this angle here is 30. So, this is a straight, that's 30, that's 90, that's 60.
That's 30.
Yeah, well hang on, I'm getting there. That's 60, this is a straight line.
Green to black.
Okay. Where else is 30 now? This is 30.
The angle to the normal.
This is 30.
To the red is 30.
That? No.
No, because
That's
your
30.
drawing is wrong. No, your drawing is wrong.
What? This is 30, true?
Yeah.
Okay, that's 30.
The red
And this is
line
60.
should be straight, not reflective.
Ah, but this is red and green on top of each other. I'll just do it as black. Yeah? This is what he thinks the fish, or where the fish is, and this is where it really is.
No.
Oh, sorry, I wrote that back. Sorry. No, I know that now. Real.
No.
Think.
Real.
Yeah.
Thinks.
Yeah.
Okay. If that's 30, that's 60, that's 30.
Yeah.
Yeah.
Wait.
No.
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 Yeah, that's 30 and that's 60.
No, 30
Yeah.
is the one he thinks. It's 30.
No, 30.
The real one is 22.
Yeah, the real one is 22.
Yeah, real one is because your line is wrong.
What
The-
line?
The red line should be straight from
Straight,
eye,
yeah, it should be what he thinks.
and green line should be reflective.
Ah, yes, thank you, KJ. I do, I have it backwards. Okay, let me try again. No, just be quiet, don't distract me, and I'll get it. Okay, so, we'll put the fish here. And let's just be clear, this is where it really is. Okay, and this is where it looks like, this is where he thinks it is. Yeah, and this is a straight line. Hold on, steady.
It's not.
Close enough.
No, but it's reflective.
Shh, be quiet. Well, and then this one here, this is where it really is. And this diffracts, so it looks like it's here. Okay, great. And this is 30. Yes? And so this is 30. Okay. What? Okay so far? Yeah. Right, so let's write down, this is N1 is 1.33. N2 is 1. Theta 2 is this angle here, isn't it? Oh yeah, this one here. Well, that's also 30, isn't it? So theta 2 is 30. Okay, so what's theta 1? If we use this information, we get 22.1 degrees. So that's, let me see. this one here is 22.1. Good, okay. Now, we know that it is really 1 point, what did I say? 2. So, we have this triangle here, but we want to actually get this distance here. Okay, so let me see. We've already worked out this one here. This is, what's this? 1.2 tan 22.1? Yeah? I want to know this. I want to know this distance here, please. 0.6928. No? X.
Why?
X over 1.2 equals, yeah, 1.2 tan. Yeah, what's that, Monica? 4.487.
Yeah.
0.4. Okay, good. So that's it really. We know this angle here. What's this angle? 30. And we know this distance here. So can we get this distance? Yeah, so we'll just say tan 30 equals 0.4873 over x. So x equals 0.4873 over tan 30. What's that?
0.844, the same as this.
0.844. So same answer. If you're happier with that way, wonderful.
But isn't it the same method? I mean, you
It's the same method, it's just thinking about it differently.
People got thing is, our point was, like, when you extend that line, the real line,
Yeah.
looking line,
Yeah.
which point we are looking at,
Here.
why? It could be there,
But he couldn't think it's here. If he sees a fish at the bottom of the ocean, he can't see it under the ocean bed. Do you know? So like he sees a fish. He knows there's a fish that's at the bottom of the ocean. It's on the ground. Like, okay, I said it's a fish, but it doesn't have to be a fish. Maybe, instead of a fish, maybe we make it a stone on the ground. You can't see it here because it would be looking like it was under. No? Not clear? It's getting a bit complicated. You want to know where could it be here. But I suppose what's happening is the depth is being reduced. So it's making it look less deep. So this has to move vertically upwards.
Yes, right? What do you think?
If you're looking at the bottom of the river and the effect is to make it look less deep, then this in physics is called a virtual image. The virtual image would have to move vertically upwards from the real image.
Okay.
It's not going to get pushed to the side because the effect is just to make it look less deep. Monica! I have, no, I do not. Earlier, I asked you to calculate, what was it? 1.2 over 0.844. And I put cos 30 here. Well, we need another function that has the value of 1 at 0. So not tan. No, sine doesn't. But or wait. Tan 0 is 0. That's not going to work. No, I don't think it will be tan. But out of curiosity, what happens if I put tan here? What do I get? If I put a tan here, what if I make it tan 60?
Tan 43.
2.4.
Ah, okay.
Tan
So,
43 teacher.
simple formula for it.
Tan 43
Yeah, but that's so random.
Yeah, what I was trying to do, Lee, was to try and figure out there's some simple extension to the formula to account for an angle.
Yeah, but it's tan 43.
Exactly.
43 is the angle that we do wrongly.
Could it be a critical angle?
43 is 1.33.
Interesting. Anyways, I'm closing this now.